In this application, a store sells cashews for $4 per pound and peanuts for $1.50 per pound. The manager decides to mix 10 pounds of peanuts with some cashews and sell the mixture for $2 per pound. How many pounds of cashews, which will let equal C, should be mixed with the peanuts so that the mixture will produce the same revenue as would selling the nuts separately? So when we scan, we notice some of the numbers have dollar signs, and some of the numbers here don't have dollar signs, but they're followed by the word pounds. So we have two categories of numbers. We've got pounds, and we have dollar value. What we're mixing are cashews and peanuts, and the mixtures have different dollar values. The cashews sell for $4, and the peanuts sell for $1.50. So I'm going to mix cashews and peanuts to get a total. Now if we look back, we can see that So when we look back into the problem, it says the store sells cashews for $4 per pound and peanuts for $1.50 per pound. The manager decides to mix 10 pounds of peanuts. So we actually know how many pounds of peanuts are needed this time. So instead of P, I'm going to use 10, because we actually know 10 pounds will be used. What we don't know is the total number of pounds. So that's where I need to use a variable for this particular application problem. Now I can take into account the dollar values. Cashews sell for $4. So 4 multiplied by the number of pounds of cashews will be added to 1.5 multiplied by 10 pounds of cashews, and that will be equal to our total value. Now it says that we're trying to sell at $2 per pound. So $2 multiplied by the total number of pounds. Since we don't know the total number of pounds, I have to keep my variable t to represent total pounds. My two equations now for the system come from C plus 10 pounds equals T for total pounds. C plus 10 equals T. The next equation is 4C plus 1.5 times 10 equals 2 times T. Now it would be helpful to know how much 1.5 times 10 is equal to, and when you multiply those you get 15. So if you wanted to write that as 4C plus 15 equals 2T, that might be more helpful. Now we can see from the first equation it's already written in terms of T, so we can take C plus 10 and substitute that for T in the second equation. Now we have 4C plus 15 equals 2 times this new value of T. C plus 10 is that new value. If I distribute 2 to each term in this quantity, I'll know what each individual term is. On the left, 4C plus 15 now equals 2C, and 2 times 10 means plus 20. This time I've got a variable on each side of the equation and a constant term on each side. So I have to make sure that I'm going to collect all variables on one side. I'll subtract 2c from each side so that I can eliminate it from one side and collect it on the other. I now have 4 minus 2, which is 2c plus 15 equals 20. If I subtract 15 from each side, I'll be able to collect those constant terms. I now have 2c equals 5. When I divide by 2, I can solve for c. 5 divided by 2 is 2.5, or 2.5. So that 2.5, representing the variable c, that tells us that's the cashews at $4 per pound. So 2.5 pounds of cashews are needed. Now we also need to figure out what the total number of pounds are. So I'll go back to that first equation. C plus 10 equals T. We know that C is 2.5 pounds added to 10 pounds to make the total number of pounds. It looks like 12.5 is the total number of pounds in that mixture. So we solve for both of our variables now.